the robotic manipulator to do very diverse kind of experiments, including trying to understand if Mars can support life. And this was back in the 1975. Similarly, we had Venera series of robots which were launched to study the Venus, and Mars 8 or Mars series of robotic landings by the USSR, which were sent to study the surface of the Mars. And of course, everyone knows about the Apollo missions. So Apollo missions were human or crewed missions, but they also had a car called the moon buggy, on which they would ride around the moon. So that was also robotic. And in the space domain, we call a system robotic if it has some kind of manipulation or actuation. So all of these examples that I'm giving here, even the Robotics arm, it was on board the space shuttle in 1993, and it was used to demonstrate how robotic arms can help in the space station in microgravity conditions. And also the Sojourner robot and the Opportunity, the Spirit rover, all of these were launched by USA to study Mars. So these were the very beginning of space robots. Space robotics is not a new subject. It's been there for many, many years. So the question is, why do we need robots? What is the need? Why can't humans do the same thing in space? So first answer is space is hostile. The microgravity conditions, space radiation, extreme temperatures are very hostile to humans to work there, and the difficult tasks are not possible for humans to do, like construction of habitats, on-orbit servicing, in infeasible locations, and humans have to wear all the protective gears and gloves and space suits. So all of these limits the capability of humans to do all these kind of tasks. And that's where robots and different shape of robots, different capabilities of robots can come into play. Of course, deploying robots are less risky and cheaper than launching humans and risking the human life in such unknown and harsh environments. And also robots do not really go through mental breakdown or depression during isolation or long duration space flights. So these are the main reasons why we deploy robots for space exploration. There are primarily two categories of space robots. One is the orbital robotics, the other is the planetary robotics. Orbital robotics are robots that can work in the orbit, so in like around Earth or around Moon, on the orbit of Mars. So they can do different kind of operations, such as like surveying and monitoring, but also services of refueling or space debris removal, or even microgravity research on the orbit in the microgravity conditions. And then there are planetary robotics, which are basically the probes for scientific exploration, and they are the precursors of human expedition to all the remote celestial bodies. So this is how we categorize space robots, of course, and then we break down into the different design challenges or different, challenges that we have in this domain. So coming to the challenges, there are, of course, multiple challenges that are to be solved for future space robotic missions. And mainly, we want our robots to be efficient design and be very reliable. They should be able to move around or traverse in diverse terrains, because we do not really know what kind of terrains they will encounter. So at the same time, they should be autonomous or semi-autonomous. So basically, they should be intelligent enough to make some decisions on their own and not wait for commands from the operator on Earth. Of course, being able to conduct different scientific studies and conduct experiments. So this is a big challenge of how do you design your payloads, or how do you design your experimental modules on the robots that are going to space and are going to different celestial bodies. So that's something very crucial. Landing systems are very important. We really want our robot to land safely if it is in a celestial body like Mars or Moon. So unless they land safely, they cannot really do any kind of tasks. So again, guidance and navigation is a big challenge because we do not know the environment well. We have to, like rely on the guidance, navigation, and path planning mechanism that the robot can generate by itself. Human-robot interaction is a big challenge for near future missions where we will have more and more astronauts and robots to work with on the surface of Mars and Moon. Remote operations is a big challenge where we want to control the robots from Earth or from the orbit of, say, from the space station. If you want to control your robot on the moon, there is still some delay. So these remote operations are a big challenge to overcome. Swarm and modular robotics. This is a very popular topic now, and we want more and more team of robots working together. And as you have more numbers, the coordination becomes a challenge. If you want modular robots that can change their configurations or they can do different kind of tasks, then that again becomes a challenge in terms of coordination and control. Also, we want our robots to be self-repairing because we cannot just go to space and repair them if something goes wrong. So having some self-repairing robots would be very useful. Shape transforming and origami robots. So this is also a growing research in terms of robotics in general, as well as space robotics, because in space, we want the robots to access different kind of locations, like maybe access the caves on the moon, as well as go in very deep trench or deep skylights of on the surface of the moon. And in that case, you cannot just have a rover go into it, a wheel rover. So they can change your shape, like the wheels can become legs and just go to the required location. So this is a big challenge as well. In situ resource utilization and manufacturing. We want to have our robots do all the different tasks on site, that is in situ on the moon or Mars, because we cannot send more and more resources to these faraway celestial bodies. So we need to have robots that are efficient enough for resource extraction, resource utilization, etc. Mass and power are big limitations for space. We cannot spend or send big robots or big systems into space because it's very, very expensive to just leave the Earth's atmosphere. So that becomes a big limitation, and we cannot have very big robots that can do everything on their own. So this is a challenge again. Testing and qualifications is a big challenge where you really have to make sure that your robotic systems are working properly in the space environment. but that is not very easy on Earth because we do not have that kind of conditions. We can create some analog conditions or we can simulate them, but that's all we can do unless until and unless we send several missions to space, we cannot really qualify them or get enough data to understand how to test these systems. So as we go on with more and more missions, only then we can solve this challenge. And of course, protection from harsh environment, as I already mentioned, space is very harsh and hostile. There are several different factors that can damage your structure or electronics, and you need to be careful to protect these so that the mission can sustain for a longer time. So maybe some of you would be working on these kind of robots in the future. So these are something you can think about and try to solve the different problems that we have in this field. Today I'll be mostly talking about 3 challenges briefly. That is mobility in diverse terrains and what are the different research that are going on, the autonomous capabilities, and the science payloads or experiments that are being done by different rovers or different robots currently that are operational. So as I mentioned, mobility, locomotion, and autonomy and intelligence, and sample acquisition and analysis. Coming first to mobility and locomotion, to maximize the performance and power efficiency, we need to have substantial understanding of the traction or the traversing conditions of the robot on the surface of that body, or not even surface, like if it's just moving around, such as in an asteroid, which has a very low gravity, then we need to design our locomotion system accordingly. So the most popular and the most well-known one is the wheeled robots, which are also called the rovers, and they can easily move around on the surface of Mars or surface of Moon, basically, where there is hard kind of surface, or maybe even loose soil is okay for rovers. And this is the current situation, that all the rovers that we have on Mars or Moon are very slow. They'll move at a very slow speed. So growing research in this field is how to make these wheeled rovers faster, but safer, because the faster they move, the more area we can explore. Next is the limbed robots. So limbed robots are very interesting robots which can enable us to go up into steep and uneven terrain, like climbing a hill or a wall or a ceiling of a cave. So there are different caves. There are many caves near the polar region of the moon, and it is supposed that there is some water ice trapped in these skylights or caves, and for that we cannot have wheeled rovers to go into these kind of very uneven terrain, and that's where the limbed robots can come into play. So there's a lot of work going on in NASA as well as in Space Robotics Lab, where I am working. We have several different topics of research in limbed robotics. The third one is the flying robot. So areas where you can have thick density of atmosphere and you can create some drag, there you can have flying robots. So like on Mars, we have the Ingenuity robot, which is flying around and taking pictures and monitoring and surveying really large areas. We will also have a flying robot called Dragonfly for Titan, which is the satellite of Saturn, the natural satellite of Saturn. So these kind of environment can support flying robots, and this is something that is very interesting, where we can have like drones, quadrupeds, quad drones or octodrones that can fly around and take pictures and even do different kind of experiments in the surface, like aerially. The fourth one I want to highlight is tumbling and bouncing locomotion, where we have very low microgravity and you cannot really have the rover or the robot on the surface. You need some kind of mechanism where it does not stay on the surface for very long and it just tumbles around, or just like a just bounces around. And this has already been proved, this technology, by DLR and Japanese aerospace JAXA on the asteroid Minerva, on the asteroid Ryugu, as part of the Hayabusa 2 mission. So if you just Google Hayabusa 2 bouncing robots, you will find different kind of robots by the German Aerospace and the Japanese Aerospace Agency that was dropped on the asteroid surface. Again, the fifth one is floating mechanism, because we have some very interesting moons such as the Enceladus and Europa, which is supposed to have ocean or like liquid under its surface, and there you cannot have all the different kind of robots or locomotion that I mentioned before. And there you can have some buoyant or floating robots that can go under the surface and float in the water. And similarly, we can also have some sliding or gecko or snake-like robots that can go into these crevices or openings into the water and find different kind of information from these very interesting locations. Before moving on, I want to just show this video of DLR's upcoming mission called the Mars Moon Exploration, MMX, and they are developing a robot for the natural satellite of Mars, the largest satellite of Mars called Phobos. And they do not know the environment of Phobos as much. So they have developed this is a simulation video. They have developed this very hybrid kind of robot, which can tumble and can even walk and also rove around. So it has wheels, but as you saw, it tumbled and fell down, and then it opens up and becomes like a wheel, and then it can even move its legs and walk if there is extreme terrain. So this mission is being launched in 2024. It's a joint mission by the German Aerospace and the Japanese Aerospace Agency. And we have been working on the wheels of that rover. So next is autonomy and intelligence. This is a very important topic right now in entire robotics domain. But to be honest, in space robots, in space in general, the technology is usually quite backward because there is a lot of risk and expenses involved. So we do not really implement any technology in a fluke. We want the technology to be mature enough on Earth so that we can test it for space. So as of now, uh, we do not really have very intelligent robots on the surface of Mars or Moon. We have the rover, the Perseverance rover, which is semi-autonomous. It can take some decisions on its own for its navigation purposes, but that's all. But we want to have more and more intelligent robots. And in that case, we need to equip these robots with brains and nervous system so that they can sense, think, and act. And they can, and that basically means they should have different kind of sensors and actuators so that they can sense and then take some actions using, and they should have some microcontrollers and microprocessors for to make a decision for localization and navigation and understanding their environment, and then take some action like move or manipulate or do some control actions. And this is very important because we do not know the environment where they are operating in advance. So the more autonomy we have in our robots, the better it is. So adjustable autonomy is something that we really sought after for space robotics. And there are several different approaches that we are looking into, mainly reinforcement learning. So a method where you can have the robot learn from its own experiences, just like kids learn from their experiences. They take an action, they either get punished or get rewarded, and then they understand if that action is right or wrong. And similarly, we want to have our space robots do the same. And for that, we need to train them on different kind of environment and different kind of simulations, and even in real world, and teach them which are the different actions and which are that they should be able to execute, and which are the actions that they should not execute. And imitation learning is a kind of approach where we want the robot to learn by demonstrations or by observations. So if there is an operator who can teach the robot by doing the task on their own, then that would be really good if the robot can follow and do the same tasks. So these are some important topics of research that we are currently working on for space robotics. And if you're interested, feel free to look through some of the papers out there on these topics by by the Space Robotics Lab. And also we have our partners, ETH Zurich in Switzerland. They are also working a lot on the reinforcement learning part for space robotics. So the main idea is to have achieve a balance between automation and manual control of robots for space. Coming to sample collection and analysis, there are different ways in which robots can collect samples. Some are drilling mechanisms, some are like penetrating or sending drill into the surface. Some can be like electromagnetic spectrum or cameras, or even the videos that you see here are simulation videos of the spacecraft Hayabusa 1, which was developed in our lab to collect sample from the asteroid Itokawa. So this spacecraft, it is a successful mission. It happened back in the early 2000s, it went to this satellite or asteroid, Itokawa, and it went closer to the surface, and then it sent a small ball down through a pipe and collect, and there was, after the collision, it sent some samples up, and the sample was collected and brought back to Earth. Similarly, if you followed the news couple weeks back, there was this mission, which was the Dawn mission, as well as OSIRIS-REx mission, which brought back samples from Bennu asteroid. So these are some like sample collection mechanisms that can be implemented in different kind of robots that go to these celestial bodies, like drilling, scooping, sucking, or penetrating into the rover or the surface. So coming to another question, can you name some current space robotic missions? Anyone knows of any current space robotics missions that are ongoing? No? You can write it in the Q&As. Okay, Pragyan rover. The current ones that are operational. No? We have several rovers or robots that are operational right now in space, actually. The most famous ones are NASA's Curiosity rover and Perseverance and Ingenuity, which I already mentioned, the Ingenuity robot that is flying around on Mars. Then we have the Chinese Zhurong rover that was launched in 2020. It's also operational. The Chinese Yutu-2 rover on the far side of the moon is also operational. Dexter robotic arm is on board the International Space Station just outside. It helps the astronauts to for different servicing tasks or capturing satellites or releasing satellites and different kind of manipulation tasks. So that is one robot that is currently operational. Gitai is a new company from Japan and US that are building robots for space, and they have sent their robotic arm to the International Space Station to do to help the astronauts do different tasks inside the space station. Also, we have the Japanese Aerospace Agency's manipulator, which is basically a robotic manipulator near the or on board the Kibo module of the International Space Station. And this manipulator works on like different, it's like about 57.7 foot long, and it's extensively involved in the assembly of the the Kibo module laboratory, and also the different tasks that are the experiments that are done on board here. So someone answered Pragyan rover. I don't know if Pragyan rover is still operational or not, because it worked for 2 weeks, which is basically 1 lunar day. But after that, we haven't heard back from the Pragyan rover or the Vikram lander, unfortunately. So it's not considered as a currently operational robot anymore. But I want to touch upon that briefly, because it has been a big mission for India being the first country to reach the lunar south polar region of the moon, because there have been no other country that has reached to that southern region of the moon. And it's very, very important because we all know that the south polar region, it has a lot of resources like helium-3 and also a lot of water ice, which can help for us in the future missions, future lunar missions. So everyone wants to go to this region, and India has successfully landed there. And so we attempted it during Chandrayaan 2. Unfortunately, the landing failed. But then Chandrayaan 3 in August 2023 was successful with and all the objectives of the mission were fulfilled with a safe and soft landing on the lunar surface. The rover came out of the lander. It moved around the surface, and also both the lander and the rover did several scientific experiments, which are very, very helpful for the entire space community. And of course, the Vikram lander had several sensors for safe landing. It had a guidance, navigation, and communication system, a hazard detection and avoidance system, as well as a propulsion module and a landing leg mechanism. And it also, at the end of the lunar day, on the 2nd of September, if I remember, it even did a hop experiment. The hop experiment was a demonstration to show that there can be a sample return mission. So if there is a propulsion system on the lander, it can collect samples from the surface of the moon and come back to Earth. So this hop experiments was done only to show that capability. And during that experiment, the lander elevated by 40 centimeter and then moved or landed again about 40 centimeter away. So it was a very successful mission overall. And of course, the rover traveled around. It had a semi-autonomous or more like controlled path planning mechanism. It sent back pictures of the surface of the crater of the moon, and it has a rocker bogie mechanism with a 6-wheel skid steering. So a simple rover, but very, very capable of what you can do on the moon. And they both operated for 2 weeks, which was during the lunar day until the 4th of September. And now we haven't heard back from them anymore. So we don't know if they are still operational or not. Okay, so before I end, we're almost at the end of the talk. Before that, I want to ask another question. Can you name some future space robotics missions that are being planned? Any future robotic missions you know of? I already mentioned some during the talk. India and Japan collaborated. Okay. Do you know the name of that mission? Okay. Okay, I think I'll go ahead. So one of the future mission is the JAXA's SLIM mission, which is basically a accurate landing module, and they want to precisely land on the surface of the moon. So if you know the Chandrayaan 3 lander, Vikram lander, it had a landing area of about 500 meters by 500 meters. That's quite high. landing offset, but in the slim robot lander, they want to precisely land within 100 by 100 meters. So this is something that they want to demonstrate, that if you want to land at the specific XY latitude, longitude coordinate, then we should be able to land there. And they have like very precise propulsion system and landing mechanism on board. Also, we have the MMX, the Martian Moon Exploration Mission, where there will be a satellite as well as a rover on the surface of Phobos. The Viper mission by NASA will go to the lunar South Pole, and so it will go to the lunar South Pole, and it will try to detect water ice near the surface or under the surface for future missions. The Japan-India collaborated mission, it's called LUPEX. It is being planned for 2025, and we are working on this as well, especially on the locomotion system and the traction system of the rover. And the lander is being built in India. Then the Dragonfly mission, as I mentioned, it is an octadragon, which can fly in this atmosphere of Titan. So this will be collecting a lot of data from the dense atmosphere of Titan. And the Europa lander is planned for 2028, which will land on the surface of the Europa. Okay. So before I end, since it's a space and entrepreneurship theme, I want to make sure that you know that it's not just the space agencies that are working on the space robotics missions. There are several different companies that are also working on this, and these include the Off-World Robotics, the iSpace, as well as Planetary Resources, Asteroid Mining Corporation, Gitai company, which has already launched their robots to space. And the space robotics market is going to just keep on expanding in the next decade. So it's a very big market, and if you want to get into this field, this is the time where you should, start your own company, or even work for these companies or the agencies that are working on space robotics. And India is really investing. ISRO is looking into partnering with space robotics companies. Unfortunately, in India, we do not have any space robotics companies yet. So this is your time. And of course, stay updated with the industry and academia and everything that's going on in this field. You can read more in this Space Ambition article that I had pleasure to give an interview to and tell them what are the different things happening in the space robotics field, as well as Jatan's Space is a very nice blog to follow everything that's going on in the space community, and he covers a lot about lunar robotics as well. And to stay updated, you should you should be able to build your networks and subscribe and to different organizations and kind of improve your networking skills. And if you want to pursue higher studies, master's or PhD, you can follow this link. It has a list of different universities that give courses on extreme environment robotics, and equip with yourself with different kind of softwares and tools like uh, 3D CAD modeling softwares like SolidWorks, and also programming tools like MATLAB or C++ and Python languages. And a lot of robot systems work on ROS, Robotic Operating System, which is a middleware between the hardware and the software or the sensors and the control systems of the robots. So in space as well, we are implementing ROS software, so you can like learn these different kind of systems and be prepared for the industry. With that, I end my talk today, and if you have any questions, please feel free to write it on the Q&A session, and you can connect with me through LinkedIn or through my research profiles. Thank you.
Thank you very much, ma'am, for the wonderful talk. It was very insightful and indeed informative to know about various space robotics missions and to get some more details about this field. I would, I hope we can have some questions. If the audience have any questions, please post it on the Q&A window.
Excuse me, ma'am.
Yes.
I have a question.
Yeah, sure.
So, you were talking about like people are trying to implement reinforcement learning, like learning from the mistakes. But wouldn't that be very costly? Like, if a space mission has failed, and if we try to learn from the mistake, it would be extremely expensive, right?
Right. So the main thing here is you do not want to learn from your mistake during the mission, but before the mission. So for this, we develop different kind of photorealistic or high fidelity simulators where you can train your robot models. Uh, there are different platforms where you can develop these kind of simulators, such as NVIDIA Omniverse or Gazebo or even Copelia Sim. These are different platforms where you can develop simulators, and NASA is also working on these kind of realistic simulators where they take as much data that they have from different missions that have already happened, also from satellite data and Apollo mission data or Mars mission data, and they try to create an environment very similar to the environment where the robot would be working. And then they simulate and train the robot model on these simulators. And then to bridge the gap between simulation and real world, it's a sim to real gap. It's a real thing, like a major drawback that we have. We try to reduce that sim to real gap by going to some analog sites like Ladakh or Utah Desert or some extreme environments, and you go there and you test your robots in these kind of environments and see if this is really working or not, as much as we can, of course. So that's one of the reasons we cannot have completely autonomous robotic systems in space, uh, because we don't have enough data. Secondly, we cannot train our robots 100% on Earth. So we have to take a balanced approach. And the reinforcement learning is mostly based on trying to train them on the Earth. I hope that answers your question.
So, ma'am, then what is the exact difference between imitation learning and reinforcement learning? Won't these two be identical? If that's the case.
Imitation learning is more about teaching the robot by doing it by some other operator, right? So maybe the data can be the same. You can use the same data for both kind of learning, but your output might be different. As if you have studied some of these algorithms on reinforcement learning and imitation learning, you'll see sometimes they use the same data set, but the different algorithms and the different output and the uh, policies are quite different for both these approaches. And in imitation learning, at least what we are trying to do currently, we have recently started working on imitation learning. It's basically showing the robot using a human operator to assemble or to conduct any kind of tasks, and then the robot follows the same in a slower manner with but it does the same way, like changing the orientation and for different kind of assembly tasks.
Okay, I think I understood now. Yeah, thank you.
Thank you for your question.
Ma'am, you have mentioned that there is a reward and punishment while learning. So, can you give some example? Mean, does this impact means how the punishment impact that robot?
Yeah, so you can have, it depends on what kind of policy you make. Um, I'll give you an example of a quadruped robot, for example. If you have a quadruped robot, maybe you have seen the Boston Dynamics Spot or Etihad Zurich animal robot. So these are quadruped robots. And so when these robots are moving on diverse terrain, they they cannot really move at the very beginning just by their normal control or inverse kinematics. So gradually they learn as they move by, and that depends on what kind of policy you design for them. So the policy, it has, of course, I cannot give you the entire background of reinforcement learning, but the main uh, the main basis of reinforcement learning is it has an agent, environment, policy, and reward. So the reward, the operator or whoever is developing can design it, what kind or what situation you want to reward, and give some kind of you know like plus one, usually in binaries, so plus one or minus one, or no reward, like zero. So you can penalize or give a reward to them based on where the robot is putting their leg. If, for example, if it's putting the leg in a wrong position over a rock, or uh, somewhere that it should not put the leg, and it falls off, then it is penalized. So next time the robot will not put their leg over there, and this goes on for many, many, many times. And this can take a lot of time for the robot to learn. I would suggest you watch some videos of the animal robot the learning to move on a staircase or on a rough terrain. They actually did it with reinforcement learning. So this is how they did it. Like they designed a policy where they have some specific rewards, some specific penalties for different kind of actions that the agent takes.
Yeah, thank you, ma'am. I hope I understand.
Ma'am, excuse
Yeah.
me. You were mentioning about the difficulties in maneuvering the robots.
Mhm.
So, one difficult aspect which I can imagine of is like passing. If there's a crater, it should deviate from the crater, and like what are the other possible difficulties in maneuvering of such robots?
What are the other possible, like,
Oh,
crater is actually very big. That is something that comes very later. But on Mars and Moon, we also have several rocks and boulders. So you don't want to have a collision with these obstacles. So you want to avoid these boulders and rocks and move in a different path. So in that case, the rover should be able to understand that it is a rock. It is a big rock or a small rock. If it's a very small rock, it can maybe go over the rock. But if it's a big rock, it should be able to maneuver and move and take a different path to avoid the collision. For craters, sometimes we, at least in the simulation part, or if it is a scientifically important mission, we actually want our rover to go into the crater or the robot to go into the crater. Of course, safely, either with a tether or, with a walking robot that can go into the cave or into the crater. So the Pragyan rover uh, avoided the crater because it was not designed for going into the crater. So when it encountered the crater, it retracted back by a few centimeters and then changed its path to go in a more safer and flat path. And what else it can avoid or maneuver is also, uh, once we have several different robots on the surface of the moon or Mars, of course, they have to avoid each other. So they should be able to understand the location of each of the agents and be able to communicate with each other so that they know that they do not have to, that they don't collide with each other. So that's something that they should avoid.
and also in case of a floating robot,
Mhm.
if it has to uh, survey over say a surface which is not solid, if it's a liquid or maybe a gaseous giant like a Jupiter. So in Jupiter also we can see there are some extreme conditions in Jupiter also, right? So like, are there any robots which have been designed to tackle such very drastic conditions, say in Jupiter?
So for Jupiter, currently no robots are being designed that can go into the gaseous giant. Uh, Also, one of the major, uh, you know, difficulty of going to Jupiter is that it has a very uh, high gravitational pull. So anything that goes near it will just go into it. So uh, even there are no orbiters being planned for Jupiter in the near future. Uh, the nearest we can go is to the different moons of Jupiter, which is Europa, is one of the moons of Jupiter, and Europa has some interesting water under its surface. So hopefully we can have a robot there and discover some new things. But Jupiter, no. Like there are different satellite missions that are observing Jupiter from very far, like the Juno mission, that is trying to understand the different phenomena that are going on in the gaseous giants. But that's very far, not not near Jupiter.
Okay, thank you.
We have one question in the chat about the Pragyan rover. So I'll read out the question. The Pragyan rover was not able to be woken up because the components were not designed to survive the lunar night temperature. So how are components usually designed to withstand such extreme environments?
So there were two main reasons why the Pragyan rover did not wake up. One is, of course, the components, the electronics were not designed to survive the very cold lunar night. It goes even like low as minus 200, minus 230 degrees centigrade. So the electronics usually cannot survive such low temperatures. But there are, of course, ways in which you can protect the electronics using, thermal protection, having some heating mechanisms inside, which can keep the electronics warm during the lunar night. And I think the Pragyan rover did have some thermal protection such that the electronics can survive. But the main drawback for Pragyan rover and the Vikram lander was the power. Both of these were powered by solar, as I had shown here, specified here. Both were powered by solar panels. And once you have the lunar night, it is completely dark. You do not have your heating mechanisms working on this in this lunar night. So everything just goes frozen in that low temperature. So one of the future considerations can be to use nuclear thermal RTGs with like radioactive thermal generators, which is being used by the Perseverance rover and the Curiosity rover on Mars, as well as the Chinese, the U2 rover also uses so this one on the right top, U2 rover by China, they also use the nuclear power. So nuclear power goes on operating until it is completely decayed. So every time at the end of the lunar night, it again wakes up and operates as usual. So the nuclear power keeps it heated up during the lunar night. So that is something that should be considered, I think, in our future missions. See another question. While planning the lifetime of a space robotic mission, do we also consider what happens to it at the end of its life? What has been done in past missions for? Yeah, that's a very good question, actually. So far on Moon, most of the missions that have been there on the surface of the Moon, at the end of their mission, they just stay there. There is no atmosphere on the Moon. There are not many factors that can, damage these missions. So they just stay there. There's life. Maybe in future, when we have more human missions, we can try to revive or bring back these systems to Earth. But for now, they are just staying there, and there's no consideration of end of life for the Martian missions, for the Moon missions. For the Martian missions, the same thing. They do not have any considerations, but as we know, Mars is potentially more capable of supporting life. As of now, we have several evidences that it has supported life previously, or it can support life in future. So this is something that is being considered to have the rovers that are operating there move away from these potential habitable areas. So they do not stay near the Jezero crater or near the lake kind of areas where they have found some evidence. So they just move away. Then there was this Cassini and Huygens mission, where the Cassini went near Enceladus, the moon of Saturn, Enceladus. It went there and it collected samples, and it realized that there is organic matter in Enceladus. So it realized that they cannot just at the end of the mission they cannot trash the robot or the spacecraft just like that. So they decided to maneuver it and take it near the Saturn, which is a gaseous giant, and it crashed into Saturn, the Cassini spacecraft. So, because Saturn does not support any life or does not show any kind of evidence that it can support life as we know it. So in future, we cannot have different kind of robots that are going to Enceladus and Europa, especially where they support organic materials. We cannot have these kind of robots just dumped over there. These they are considering bringing back these spacecrafts like the Europa Clipper, the Dragonfly also, because Titan also has some organic materials in its atmosphere, which can support chemical life, for example. So that's something that is being considered for these kind of surfaces where there is possibility. If nuclear energy is dangerous if the mission fails? Yes, if the mission fails, it is dangerous, and that's why there are several regulations of how you should use nuclear power, and we can only use nuclear power if we are sure that the mission will not fail. So hopefully you just have to be more and more confident that okay, after a lot of tests and qualification, we can assure that we can use nuclear energy. But if it does not fail, if the mission is successful, then it's absolutely safe to use nuclear energy. Even after the end of life, the nuclear energy deteriorates, and in future maybe we will use nuclear fusion. So hopefully that will be something we can have clean energy for our missions. And that's one of the reasons we want to explore moon more and more, because there is hydrogen 3, which can give us clean fuel for future missions. Okay, I'll take just one more question that is in the chat. Can space robots be used for space mining? And how important are sample return missions for this? What kind of results can we expect from such an endeavor? That's a very good question. And in this slide, several of these companies are actually planning to mine asteroids and moon and bring back precious resources to Earth. I personally do not like these kind of missions or do not approve of these, but there are no regulations as such yet to bring back samples or precious materials from asteroids that can be used on Earth. Yes, space robots are being developed, even by Asteroid Mining Corporation and Off-World Robotics. They are developing robots that can extract resources on the asteroid and bring it back. And I hope people who are making the policies and uh, not people who are making, but our generation and your generation be more mindful of what we are doing, and we get into this field more actively and try to be more sustainable in our actions of what we are designing for our future missions to space. Of course, we don't want the asteroids and moon to become what has happened on Earth. We have mined several places absolutely mindlessly, and we do not have resources left anymore. And so we are looking for resources outside of Earth. But we need to be very careful about this. So, what kind of results can we expect from such endeavor? Uh, there's in terms of technical development, it will still take at least 15 years for the technology to mature. But once they mature, there are a lot of things that they can do and bring back extracted materials. So there has to be some policies set for moon mining and asteroid mining activities.
Thank you very much, ma'am, for taking this time to answer these questions. And thank you very much for this interesting talk. I believe all of us really enjoyed this talk, and it was very insightful for us as well. So, thank you very much, ma'am.
Thank you
Have
so
a
much.
good night.
Thank you. Bye.
Thank you, ma'am.
Hello.